Welcome to this ADF Insider Basics seminar. My name is Shai Schmelzer. I'm a Senior Group Manager at the Oracle Development Tools, and in this seminar we'll give you an introduction to the Oracle ADF Business Components. This is an ADF architecture diagram, and the layer that we're going to focus on today is the Business Services layer. The Business Services layer is responsible for allowing us to interact with our data sources. Specifically, it is responsible for doing things such as manage the persistence of data to our databases, which involves handling object relational mapping between Java objects and relational tables in the database, executing queries and data manipulation commands against the data in the database, and also performing validation and running business logic in our business service layer. Oracle ADF allows you to base your business services on various technology. You can choose to create your business services using JPA entities, simple Java classes, or web services. And one specific technology that ADF offers you is called the ADF Business Components layer. ADF Business Components is part of the Oracle ADF framework that is responsible for simplifying the way that you build Java EE-based business services that interact with the database. It focuses on delivering a familiar development approach for developers who are coming from a 4th-generation language tool such as Oracle Forms, Power Builder, or Visual Basic. And it provides a very declarative approach to creating those business services, and it is aimed specifically at people who feel comfortable with the concepts of relational databases. In functionality, Oracle ADF Business Components is responsible for simplifying the way that you access the data. It also simplifies the way that you write business logic on top of this data. It uses SQL as the way to define the views of the data that you're getting. And it has a strict separation between the actual data views and the business logic and validations in your application. The framework also implements a lot of best practices that have been gathered over the years as design patterns for Java EE application. And at the end of the day, you get an application that is very easy to customize later on. So ADF Business Components provides the data interaction and business logic execution layer in an Oracle ADF application. It maps to a data source, usually a relational database, that can be an Oracle database or a non-Oracle database. And it focuses on a 4GL approach for development, which means that a lot of the development will be done through declarative wizards and visual editors for your components. Most of the development of ADF Business Component is actually done through metadata definition rather than actually writing low-level code. You do, however, can write business logic in the ADF Business Components layer. Again, most of these business services rules can be applied using a declarative approach, but in specific cases you can also resort to Java coding to handle more complex rules. At the end of the day, your application model can be exposed and be used by various UI developers as well as a web service interface for remote developers who want to interact with your business services. The development that you're doing with ADF Business Component uses a combination of Java and XML to achieve the results. Let's look at the architecture of ADF Business Components. There's actually a separation of ADF Business Components themselves into 3 layers. The first layer is comprised of entity objects. Entity object represents tables in your database, and they map to tables in your database and allow you to execute insert, update, and delete operation against those tables. The entity objects are related to one another using associations. The next layer of ADF Business Components is composed of view objects. View objects represent sets of data that you interact with. Those can be updatable or non-updatable views of data. And view objects can also be related to one another using view links. The last layer of your ADF Business Component application is called the application module. The application module exposes the interface that the user interface designer is going to interact with. The application module is responsible for handling the connection to the database and the transaction management, and it exposes a specific data model for your developer. The data model is constructed out of view object, view links, as well as service methods that are written inside the application module level. Let's look at each one of the layers of ADF Business Components and focus on the functionality that they provide. The entity object actually maps to a row in the database table. It consists of attributes that map to the columns in the table, and it handles the insert, update, delete operations against the table. In addition, the entity object is where you're going to define behaviors for attributes and all sorts of validation. So if your table in the database consists of specific columns, when you're creating an entity object, you're going to map those columns to specific attributes in your entity object. In addition, you can add validation rules to those attributes as well as to the entity level. Association represents relationships between entity objects. In many cases, those are going to map to relationships defined in the database through foreign key primary key relationships. But they can also be independent of any relationship defined in the database. Associations are used to access data in one entity object from another entity object, and therefore are very useful in the definition of list of values as well as validations. A view object represents a query, and because it uses SQL to access the data, you can use all the SQL functionality to define the set of data that is represented in a view object. This means that you can use things such as joining, filtering, projecting, and sorting to create a very specified set of data for your business service. Many views objects can be defined on a specific entity object, and they can also span multiple entity objects. A view object can be constructed from a SQL statement, as well as have its values statically typed into it or be populated programmatically through a piece of code. There are two types of view objects, an updatable view object and a non-updatable view object. A non-updatable view object is simply a query defined against the database. It returns a result set, and this is the object that you can use to display the data in your pages. An updatable view object, however, is based on data coming from entity objects. Whenever you're going to execute an update, insert, or delete, the actual operation is going to be executed by the entity object. When you're fetching data, the data is being fetched into an entity object and then into the view object. The entity object, in turn, can manage a cache of the data across multiple view objects. The application module is responsible for defining the data model that is going to be exposed for the developers who are going to use your business services. The application module also controls the connection to the database as well as tracking the transaction state. The application module can provide, in addition, remote accessible methods, service methods that can do specific operations on your data. Application modules can be reused across multiple applications, and application modules can also be nested to create more complex data models. Let's now look at how you actually build an Oracle ADF Business Component layer for your application. The first step is usually creating an entity object, and this involves mapping to a database table, choosing the specific attributes you want to use, and setting attributes for those, or setting properties for those attributes. We'll switch now into JDeveloper and show you how to build this layer. We're going to create a new application, and we're going to use the Fusion Web Application template for this. When we create a Fusion template based application, we get two projects. One is responsible for the user interface, and another one is responsible for our business services. We're going to create a new layer in our business services tier, and we're going to use the ADF Business Components. Now you can actually go and define an entity object and then go and layer it with view objects and finish everything up with an application module. Or you can do it the quick way by using one dialog that creates all the three layers. So we're going to use this dialog called the Business Components from Tables. First thing to do is define a connection to a database. Name the connection, choose the type of database you're connecting to, and specify username and role as well as database connection information. Once you're connected to the database, you can query the data dictionary to find out which tables you have access to and choose the tables that you want to be able to update. This is the first step in the wizard, and it's going to create entity objects. We're going to place our entity objects in a specific package and we'll call it EO to make the separation of layers in ADF Business Component clearer in our example. The next step of the wizard actually goes and create updatable view objects, and we're going to create two view objects based on the two entities we created that are going to be updatable. We're going to place those in a VO package. The next step allows us to create read-only view object. Those are not based on entities, but rather allow us to choose directly tables from the database that we want to allow our users to read data from. Again, we're going to create a jobs view object and place it in the VO package. The last step involves us creating an application module. We can also choose to expose everything in a quick diagram that will illustrate the structure of the components and their relationships. Let's look at our diagram a little closer. We start with two entity objects, department and employees. Okay. And you can also see the associations between them. Those are relationships that have been created based on relationships in the database. Once we have the entity objects, we can go next and create view objects. Again, one view object for departments, one view object for employees. Each one of them is based on a single entity. And again, there are view links that define the relationship between the view object. There is also an unrelated view object based on the jobs table, but again, because this is not based on an entity object, it's not updatable and it doesn't reflect here. The last layer of our application is the application module. This one consists of the various view objects that we want to expose to our users, along with the relationships between those view objects. Now that we created our base data model, let's go and refine it. The first thing you might want to do is define some attribute properties at the entity object level. Those are going to reflect in any view object that use those entity objects. You can define two types of attributes. Some of them have to do with functionality and behavior, such as mandatory fields, default value, and all sorts of database interaction properties. The other type is UI hints. Those have to do with the way that the attributes are going to be displayed when you're creating a default user interface on the view object. We'll switch over to JDeveloper, and in our entity object package, look at one of our entities. Let's look at the employee entity object. We can see the name, we can see the schema that it's based on. We can set all sorts of tuning parameters at the entity level, all sorts of keys and other aspects, and we can also look at specific attributes. Whenever we're looking at an attribute, we can see the properties of the attribute over here in the property inspector. Let's move the property inspector down here. Let's look, for example, at the employee ID field. We can see that this is a number field. We can see the mapping to the database, and we also can see that it's a primary key field. We also see whether it's a queryable field, whether we're going to persist it to the database, and other types of data that we can set on this field. Let's look for example at the hire date field. One thing we can set for the hire date is a default value. This can be a hard-coded value or it can be a result of an expression. We're going to use a Groovy-based expression to represent the current date as the default value for a new record created. Another set of data that we can set for the hire date has to do with the UI hints. Here we can specify things like the label. So let's call this hired on as the label, and we can also provide a tooltip. In addition, we can define a format mask, format type, and a format mask for the field. For example, let's specify mm/dd/yyyy. So this is one way to define properties for attributes. One thing to note, when we define things like UI hints, format mask, those are automatically extracted into a message bundle file, which can be then translated into other languages if we want our application to be multilingual. One more thing that you might want to do at the entity object level is define validation. Since this is the layer that is actually responsible for submitting changes to the database, we can add validation before the data is actually being sent to the database. Let's add a validation to our entity. We're looking at the salary field, and we're going to reposition our property inspector to the right and look at the validation rules that are offered here. We can already see a validation rule that was derived from the definition of the field in the database, which has to do with the precision of the salary. But we can also add additional validation rules. ADF provides you with built-in validation rules that you can define very easily in a declarative way. For example, you can use a compare validator to specify that the salary must be greater than a specific value. This can be a literal value, and it can also be the results of a query. So you can write here a query like select minimum salary from some table. This can also be the results from a view object, and it can also be the result of a Groovy expression. A key exists checks that the value that we're providing exists in another place. A length validator checks for the length of a field. A list validator allows us to offer a list of values that are allowed for this salary field, like that. Again, this can also come as a result of a query. Method validators allows us to write a Java method to validate the value. Regular expression allows us to use regular expression for validation, and script expression allows us to use Groovy for validation. Let's use the range validation for the salary field. And for the salary, we're going to check that the salary is between 0 and 70,000. Here we can condition the execution of this validation based on some Groovy expression, or leave it empty if we want to execute it always. In the next tab, we can actually specify an error message, such as salary is out of range. We can also add parameters to this error message. For example, we can reference the new value in the field. Note that validations are not restricted to a field level. You can also define validation at the entity level over here. Those can also include validations on the collection of data, as well as checking for unique key and other functionality. At this stage, it would be nice to actually go and test our application so far. ADF makes testing ADF Business Components quite simply by using the ADF BC tester. We simply right-click on the application module and choose Run. The result is a swing-based user interface that allows us to interact with our view objects. So we can look at departments, we can look at employees, and we can also look at relationships such as the employees working for each department. Few things to note at this stage. The title for this field is aired on, as we specified, with the right format mask. This is true whether we're watching it in this format or directly in a page. At this stage we can also do any type of database interaction here. For example, we can do query by example. Let's find all the employees whose last name begin with S. Remember our salary validator, we can also test this. Let's put -9 as the value. When we try and leave the field, we'll get our error message saying salary -9 is out of range. Next, let's turn and learn how to create view objects. We already created some base view objects by running through the wizard that we saw before. Now let's create some other view objects. The steps for creating a view object is to define the type of view object, define the data source for the view object, choose the specific attributes, set properties for those attributes, and potentially modify the query if needed. In our example, let's create a new view object. And we'll call this one the highly paid employees. Again, this can be based on an entity object and allow us to update data, or it can be a read-only SQL-based view object, which is what we're going to do now. Then we need to specify our query. We can use the query builder here to specify the fields that we want to see. And here's our query. Since we want to restrict the list of value, we can also add a where clause that says where salary is bigger than, and we're going to introduce here a parameter called p-minimum salary. We can also add an order by clause to this to show the data in a descending order. Let's test our query. Query is valid, so we can continue on. Next step will actually have us define a variable for our query. And that's the variable we're using there to select a specific set of data. You can give a default value here of 0. For each attribute we can set properties such as which is the key attribute, whether and various other functionality. Last step would have us expose this view object in our data model. And let's save everything and run our application module now. This time around we have the highly paid employees as well. When we access this view object, we're prompted to provide a value for the parameter. So let's look for employees with salary over 10,000. And we can see those employees appearing here. You can also choose to see this in a table. So we saw how to define a view object, and we also saw how to use named bind variables inside the query in order to filter the data. One nice thing that ADF Business Components allow you to do is define view criteria which are able to be added dynamically to the view objects. This way you don't force users to use one view object for each query, but rather have a view object that can be used across multiple queries. Let's define a new view criteria for the employees view. Double-clicking the employees view, and we're going to go to the query tab and add a new view criteria. Again, we can add a criteria called highly paid employees and add a condition that says that the salary field must be greater than either a fixed value or a bind variable. Let's define a variable and that would be one criteria that we can use on this view object. Another criteria that we can add, let's call this employees with string, and over here we can say something along the lines of first name must contain some string. And we can make more complex rules by adding another condition and saying that not only first name can contain it, it can be either first name or the last name. So those two view criteria are associated with the employees view. Let's save everything and run our application module to see how we can use those. If we're looking at our employees view, we can see all the employees right now, but we can also apply specific view criteria. For example, look for highly paid employees. Specify a value, and we can see that there are no employees earning that amount of money. If we remove one of the zeros, we can see those employees who are earning more than 12,000. We can then add another condition or remove one of the conditions, and for example look for employees who have SC somewhere in their name. For example, this guy. So far we saw view objects that are based on a single table, but in many cases we actually want to represent data from multiple tables. There are two types of joins or linking that we can do between view objects. One of them is to create a view object that is based on a join query. This will represent data from two tables in a single line or a single object. Another type of linking is called view link, and this allows us to create a master detail type of relationship between view objects. Let's see how we create each one of those. First, we'll create a view object. We'll call this view object the emp translated view object. It's going to be an updatable one, and therefore it's going to be based on entities. The first entity that we're going to choose is employees, and this is going to be an updatable one. But we can also base a view object on more than one entity, and in this case we're using the department as the secondary entity. We can mark this as an updatable or non-updatable according to what we want. We'll leave it as an unupdatable reference. Then we can choose the specific fields that we want to show, along with fields from another entity. This creates a join query for us that we can see here. Let's expose this in our application module. Click Finish, and that's what we call a join view based view object. Let's look at emp translated. We can see not only the details from the emp table but also the name of the department coming from the department table. Note that this is non-updatable because it's coming from an entity that we referenced as non-updatable. Let's now look at the second type of view linking, and that's through the usage of view links. We already saw the references to view links when we looked at employees working for a specific department, and as we said before, those view links can be derived from relationship in the database, but they can also be applied without any relationship existing in the database. For example, let's look at our jobs view, and we can define a new view link that will connect the jobs to employees. We'll simply select the field that connects the two, which is job ID in this case, and choose to expose the relationship in our application module. Now, not only can we look at specific jobs, we can also look at the employees working in each profession. So the view link gives us this master detail relationship. View links also enabled us to create master detail relationship between department and employees, and also recursive relationships, for example, between an employee and the employees who are working for that employee, which can be represented in a tree over here. Another common task that we use when working with data is to provide list of values for specific fields. In many cases, those lists of values are coming from other sets of data. So let's see how we can define a list of value for a field very easily in ADF Business Components. We look at the employees view, and we look at specific attributes. There's the job ID attribute. This contains the job ID for a specific employee. What if we want to display the actual name of the job? In this case, we can create a list of value. We'll call it the job list of value. We'll select a source for this, and this is going to be the jobs view. Specify the field that connects us to this, and then define how our list of value is going to look like. Let's look at combo box with list of value. We're going to show the job title, and we can set all sorts of query parameters over here as well. Save everything and run our application model. Now when we're looking at employees, we can actually see the job name over here. We can also choose to change the job name, and we can also do queries in a list of value way. For example, we can ask to look up all the jobs that begin with M. Select the job that we want and assign it to the employee. At this stage, you can either commit or roll back any changes you've made. The commit and rollback are handled by the application module. The application module also handles the actual data model that you're seeing when you're running the application module tester. That's the data model that is going to be exposed to your end user UI developers. The commit and rollback are two operations that are exposed at the application module level. Another thing that the application module is responsible for is defining the data model that is going to be exposed to the people who are going to use our business services. Let's look at how you can refine this data model. You can simply double-click the application module, click the data model tab, and you can shuttle things to the right or to the left. For example, if we didn't want to display this relationship between jobs and employees, we can just remove this from our data model. We can remove any view that we are not interested in exposing, and we can also move things to the right to expose other components. When we're done with that, this data model is going to be the one that anyone who accesses our business service will have access to. As you can see, it's exactly the same representation being shown here. So, you might have been wondering, all the development that we've done so far has been done declaratively. Where is actually the code for everything that we wrote? So let's look at what we've created so far. We'll just close all of those files and look at our project structure. We start with the entity objects. Okay? And when you actually look at an entity object and you expand the node, you can see that there's just one file there, which is an XML file. If you double click on it, right, you'll actually get the same editor that you saw before. So this editor is just a visual representation of an XML file. If you actually click on the source, you'll see the actual source of the entity. For example, let's open our employees entity, switch to the source view, and look up salary. Over here, one of the things that you can see is our validation definition of the range for the salary. And as you can see, this is saved in XML, which makes it very easy to customize and modify it later on without the need to recompile your whole project. In fact, everything that we've created so far, including the application model, the view objects, view links, entity objects, and associations, are all purely done with XML at this stage. There is, however, the opportunity to add Java classes for each one of them using the Java class over here. The nice thing about ADF Business Components is that you only need to use Java files when you want to override the default behavior or when you want to implement some very complex business logic that you can't achieve declaratively. Okay? And again, Java files can be created for any one of the layers in ADF Business Components. Let's see, for example, how you can create an implementation class for an entity object and then modify things directly in Java class. So we're looking at the employees XML file, okay, and we're going to create a Java class for the implementation. We can specify what methods to actually create in there, and we're going to create just the accessors at this point of time. When we look at the Java file and we look at the methods that are available there, we can see that for each one of the fields we have a getter and a setter. And by default they all do the very basic thing of getting and setting the value. By the way, those are also available for the associations we have, so we can actually traverse relationship, for example, from an employee to the department that he belongs to, and as well as to the department that he manages. Now, the nice thing here is that if we want to, we can override any of those methods. For example, we can add something to the get last name. Right. So this way, whenever someone fetches the last name of an employee, it would be appended by the grade. Another thing that you can do at this stage is you can choose to override methods. By going to the source override method, you'll get a list of methods that are available, in this case at the entity level. Those includes operations and hook points that allow you to catch, for example, interactions with the database. So you can write some code before the commit operation or after the commit operation. Same thing goes for remove, rollback, and many other operations. One very useful such methods is to override the doDML operation and actually control fully how you actually do any manipulation of data in the database. Let's see an example by overwriting the remove method. By default, we're just going to remove the row. We're, however, going to remark that part of the line and just code an error message saying we don't allow to remove employees. Let's save our code for now and run the same application model tester. If we now look at employees, we can see that whenever we're getting the last name, there's the grade appended to it. And when we try to remove a field, let's bring up the log window, and we'll try and remove an employee, we'll get our message from the method that we overrode. Java file is also a place where you can write validations for complex rules. For example, let's take the email field and define a new validation for the email field. This is going to be a method validator. The name needs to start with the word validate, but then you can give it whatever name you want. So we're going to create a method called the validate hotmail email, and the error message is we don't accept hotmail addresses. Now the method is inside our entity object, so we can go to the method directly. And this is a Boolean method, so it returns true or false. It accepts a parameter which is the email. So we can very simply write a piece of logic here that checks whether the email ends with hotmail.com. If it does, we're going to return false, therefore failing the validation. Otherwise, we're going to return true. Save everything, and again run our application model. So can an employee and try and update his email address, and when we try to leave the field, we get our error message, we don't accept hotmail addresses. As you can see, it's very easy to override specific behaviors by interjecting just the Java code that you need for the specific operation. One other note here is that validations don't have to be coded inside a specific entity. In fact, there is a validation object that you can create validation rule independent of any entity and then reuse it across entities. So we've seen how ADF Business Component provides you with hook points to specific places where you can inject your Java code. This is very similar in concept to the triggers that you might be familiar with if you worked in Oracle Forms, or to any 4GL development environment where there are events and event-driven architecture for writing your business logic. So once you actually completed creating your business service layer, how do people access it? Well, they access it through the application module. The application module exposes a set of view objects, basically your data model along with the links, and any specific operations that you coded at the application module level. Let me show you an example of how you can write some code at the application module level. We pick up the application module, switch to the Java tab, and we're going to create an implementation class for this application module. And we're going to create a new method called delete all emps. Okay. This is going to be a void method. Like that. Because we're at the application module level, we can start working with view objects through various methods such as find view object. Can refactor it into a view object, and then we can operate on the view object, such as to execute a query, and later on we're going to do the deletion of employees. Okay. Once we have this method at the application module level, we can actually go and expose it as a client interface method. So, once we have those methods, along with all the methods that ADF provides by default on view object, how can people interact with them? Various ways. if you're actually building a user interface in ADF, for example, if you were to go and build a new JSF page, your application module will be exposed in the data control palette. Over here what you'll be able to see is the full data model that you created and exposed, including your service method, various operations at the application module level, as well as the view objects, view links, and operation theirs, as well as your named criterias, if you have any. For example, we have some on the employee view. Then it's a matter of simply dragging and dropping to creating your pages. But an application module can also be accessed directly from code. For example, it's very easy to write a simple Java class and using a generic code template, access an application module, okay, find a view object, and then start to perform operation on the view object, such as execute query, etc. So the application module can be accessed actually from any piece of Java code. In addition, if you have remote applications that need to access your business services, an application module can be exposed very easily as a set of SCA SDO object, basically providing a set of web services interfaces to interact with your business services. To do that, go to your application module, choose the service interface, click the plus, and follow the wizard to choose specific service methods and view objects that you want to expose to the end users. In summary, ADF Business Components provide a very robust framework for building business services that interact with your database. The development with ADF Business Components is very simple and mostly done in a declarative way, with Java being used just as in cases where things can't be done in a declarative way. There are well-defined hook points in the framework that allow you to override any of the behaviors of the framework, as well as to extend the default functionality that the framework provides. At the end, you get an application that is highly functional, yet easy to customize and extend. Thank you for attending this seminar. Hope to see you in another ADF Insider seminars soon.